So how this works, welcome to Talking Code, is we have a whole gaggle of questions in the Questions MD doc. And we're going to pick some of these to go through as a group. And I'm going to ask you this question, and you are going to write out your answer to it. What inevitably happens in this process is there's a lot of these things that you know and you're comfortable with and you're solid on until you have to put it into words. And you start tripping over stuff and sound like you don't understand it at all. That's totally normal. And so that's why we're practicing this here instead of in your job interviews. If you're ever curious about what my answers to these questions are, I have provided them for you. So when you're using this resource on your own, you can avail yourself of that. Right now, though, I want you to struggle. I want you to really dig deep and see if you can figure these out. So to start with, I want to take a couple minutes and pick at least 3. You can pick as many as you want of these questions that you'd like to work through together. Let's take a couple minutes for that. 2 minutes. 2 minutes. Slack me at least 3 of these questions that you want to work on together. Go. All right, start tallying these up. All right, lots of questions about Big O. So while I'm telling these up, let's do that one first. So somebody asks you, what is Big O in an interview? What are you going to do? Even if you don't feel like you have a very good answer, try to do something other than I don't know. Even if it's other questions that you would ask to try to get to it. You go like, I'm not super confident, but I think it has something to do with, make your best guess. So let's take a couple minutes on this one and go. Slack me your answer. What is Big O? All right, so send them in. All right, so I see Big O is the ratio between the memory and time required to execute an algorithm. Flatter the curve, the better. Very nice. Mathematical notation describes the complexity of a function. It's really any operation, but function's fine. Describes the worst case scenario with the longest runtime. Almost. It doesn't necessarily. If somebody asks you that question, worst case is probably what they're most curious about, but Big O is more general than that. Way to describe how fast or efficient an algorithm will work? Kind of. Has to do more with how it changes with inputs. Here's a good example of a question. I'm not entirely sure what this is. Can you provide a reference or an example of Big O, and I can see if I can respond with what I think it is? Awesome. That happens in an interview, solid. Notation that in some way reflects the scale of input, good. Way of describing how scaling impacts an operation. For example, you can use an algorithm for thousands of inputs versus only using it for a couple. Almost. So let's dig in a little more. So my answer was a way of describing how the time or memory needed to execute an algorithm grows with respect to the number of inputs. For example, an algorithm with a time complexity of O of 1 will take the same amount of time to run no matter how many inputs are given. An algorithm with a time complexity of O of n will take proportionally longer to run when given more inputs. And an algorithm with a time complexity of O of n squared will take exponentially longer to run when given more inputs. So let's dig in on that a little bit more. A good one. So if as something gets another input, if it gets the same amount slower, we say that's O of n. And we would chart that linearly. This is an important point. The slope of the line doesn't matter. It can be a steep as shit line. It can be super shallow. It's still O of n. It's still growing proportionally. So we don't talk about O of 2n or half n or 4n. In math terms, we drop the coefficient. All we care about is that it's a line. O of n squared, for every input we get, it gets exponentially slower or takes up exponentially more memory. Most of the time somebody asks you this question, they're talking about time, but it also relates to space too. So for every new input, we're getting exponentially whatever. Another common one, O of something like log n. For every, I don't know how to do this one with numbers. For every input, we're getting, I gotta guess, closer to some like asymptote. It ends up looking like that. In code, this is a loop. I got to loop over all these things and throw them on the page. O of n squared, I have to loop over everything. And for every one of those, I also need to loop over every element. Nested loops. That's how that happens. Log n, divide and conquer. Anything that's, all right, find this thing. All right, well, I figure out which half of the phone book it's in, and then I figure out half of that, and half of that, and half of that. That's log n. Why does this matter? Why do you think anybody gives a shit? By the way, like, this is what you missed out on in a computer science degree. It's just this all the time. Who cares?
So this would determine if your code has a high complexity and it's going to take a lot of memory and time to load it, you'll have that as a
Why do we ever need
indicator.
to talk about something in these terms?
Huh? Sorry, I only heard half what you said. Am I frozen?
Can you hear Sydney,
No.
Kyle?
Can you hear me?
Yes, I can hear
Well, if
you.
no one knows, then look it up. Let's take a couple minutes. 2 minutes on the clock. I'm going to ask the same question again. Let's have collectively a better answer. Go.
He's gonna be so disappointed when this happens again and no one responds to it.
Can he really not hear any of us?
No, he's not hearing anything right now. I don't think he's looking at the chat. It's like someone's got to flag him down.
I'll slack him.
I had lost my power. Now I'm back.
You don't have to
so-
slack me an answer for this, by the way. We can just talk about it, but I want to give you some time to research it.
This is kind of funny.
Oh, you're telling me that I'm frozen? Am I still frozen?
We're talking and you can't hear us.
Hang on. Let me see if my sound is maybe fucked. All right, I hear people now. Maybe I've not been hearing people the entire lesson.
Yeah.
That's a distinct possibility.
Sydney was answering the question.
Yeah.
Oh,
Sorry to throw you under, Sydney.
That's okay.
I don't know. People get tired in the last lesson of a week. Like, okay, I've been teaching 19 years. These 4 o'clock lessons, sometimes it's hard to get people to participate.
Oh yeah.
So, Sydney, go ahead and give me your answer.
That was funny. Okay, yeah. So hold on. I had to re-get it. You can use the Big O to test to see if your code has a high complexity. You can see that you can see where it falls on that scale, on whether it's taking a long time or too much memory, and you can use that as a reference to refactor your code to simplify it so that you can flatten that curve.
Excellent. Very nice. At really small input levels, it doesn't matter what the complexity is. And so it can trick you into thinking that, all right, good to go, ship it. And then it's successful. And so it gets 100 users, 1,000 users, 10,000 users, 100,000 users. If your fundamental design of this was such that you can't keep up with that, uh-oh. The more successful you are, the more you erode your margin. Ooh. So that's why we gotta be careful about that. All right, very nice. Next question was, what is referential transparency? Oh, that girl drink first. So referential transparency, somebody asked you this in an interview, couple minutes, go. I do want you to Slack that one to me. All right, send me your answers. Solid answers all around. Keep them coming. All right, solid answers. So it's when the result of something can be replaced with that result without changing the behavior of the program. That's referential transparency. So function returns high, you can replace that function invocation with the string high and it works exactly the same. Not every programming language is referentially transparent. JavaScript is though. It's a functional idea. Okay, very nice. So, let's see. Ooh, good one. What's the difference between a procedure, a function, and a method? Love it. Cool. So, a couple minutes. What's the difference between a procedure, a function, and a method? Go. All right, slack me what you got. All right. We're pretty close on this one. A couple of you were spot on. Most of us are 60% of the way there on this one. So let's talk about it. So a procedure is stored instructions. A couple of you said it doesn't return anything. It can return things, that's fine. But procedures are like core to procedural programming. Just some repeated step that we want to be able to invoke whenever we want. Functions come from math. A function turns inputs into outputs. A method is a procedure on an object, not a function on an object. So most methods work with state. So they're either returning back some state, they're changing state, they're combining state, manipulating it. But if OOP is all about state and behavior and having them together, methods are the way that we work with the state. Because remember, there's no way we can access state directly in OOP. It's always via these methods. In practice, you hear these three things used more or less interchangeably, but they do mean three different things. Easiest way to tell something's a method is it's got a dot in front of it. There's no methods that don't have dots in front of them. So, and then if something doesn't return something, it's not a function. Procedure. And if something's pure, then it's a function. And if something has side effects, but doesn't have a dot in front of it, it's probably a procedure. Cool. Questions about that?
In a way, are procedures like algorithms?
Yep.
Are there
Well,
differences?
like functions could be too. But like it has to do with how they're wrapped. So like, I'll give you an example. So I could write the same thing as a procedure and as a function. I did function let count equals 0 increment. That's a procedure versus that's a function. Like algorithmically, they're the exact same thing. But that one's an instruction that's operating on some state in the application. This one is performing a mathematical pure operation. Other questions about these?
We're probably writing more procedures generally than an actual pure function, correct?
When you're starting out, that's super common.
Okay.
So like any loop is a procedure?
Not necessarily. Now I'm thinking about that. Kind of functions the same way, doesn't it? The block of a loop. I'm going to go with no, because it's stored separately. It can't be invoked separately outside of the loop. I'm going to go with no. But you made me think.
Is it a method then? So if it's
No, it's a block.
oh, a block. Okay.
Other questions about this? All right, let's see if we can get 2 more in. Let's do. Let's do what's an API? That's a good one. What is an API? A couple minutes on that. All right, answers in. Good answer, Rodney. Any other ones coming in? Cool. So we're not awesome on this one. We're like 30-40%. So let's talk about it some. A lot of you gave a great definition of a web service, which is how we generally use that term API. Oh, is there an API for that? Did you build an API? Did you fetch over your API? That's a colloquial use of it, not a specific one though. So this whole thing, we have we have a client, we have an API, and we make HTTP requests. So we call this an API, and it is one, but more specifically, this is called a web service. An API is way more general than that. So if we think of every program as a box that turns various inputs into various outputs, the API is these parts. What's the contract? If you give me these inputs, I will generate this output. That's the API. You could say that the API of this function is that it does this side effect, but otherwise takes no inputs and returns undefined. That's the API of it. API of this one is that it takes in two numbers and returns their sum. That's the API of this. For the web service, if you send me an HTTP request that's formatted this way to this path, I will give you back this thing from the database. The point of it is that we can work with the contracts without giving a flying fuck how it's implemented. Doesn't matter. Maybe there's monkeys in here making this happen. Not our business. What we care about is the API. And if we can program with APIs, it gives us an opportunity to think much higher level. This is how all the different parts of our program talk to each other. This is how our different programs talk to each other. Because if you remember from anybody who saw me do this black box yesterday, this fractals all the way down. All of those things have APIs. And so on. Questions about APIs?
So it's just a catch-all term for like the inputs and the outputs of like how your code is like you know, talking to something, basically.
Yes, like specifically the contract. That's the API.
Okay.
Like the controllers and routes?
Even like broader than that, for like a Rails web service, that would be if you give me an HTTP post request to with this path in it, I will give you back a list of all the users in your application. So you'd say that's the API for that. The controllers, the router, all of that stuff, that's how we're fulfilling the API. The API is just the agreement between the input and the output.
That's how your code is interfacing with.
Yes.
Okay.
Ding ding. Yeah, anybody who didn't pick up on the acronym, application programming interface. It is how you interface with your program. And since your program can fractal like this, that could be the actual app. That could be a set of classes within it. It could be a function. Keeps going all the way down. Each one of those can have an API.
When did that change? Not change, but like the use of the word API change from that contract to a backend that has, or the web service.
Like when web services became fucking dominant like 10 years ago.
So in like an interview question, which one would they want? Like which response are they looking for? Both?
Somebody asks you that question, give them the broad answer.
Okay.
You can also say like, also people use that to refer to web services. That's the way you can sound the smartest responding to that question.
Okay.
And like it's people still use it the other way too. Now that you know this, you'll see it happen all the time. But good example, we were talking about Lodash and Code Opinions yesterday in Endeavor Devs. And we talked about data first versus data last. So in traditional Lodash, you do something that's, say, a little bit more familiar to like regular JavaScript applicative stuff. So like the way that you map, you don't dot map. Dot map is a method. So we have like some array dot map. The functional version of that, you would pass in like the thing you're iterating over as an argument. I don't like that API. I like the Lodash FP version of it, which goes like this. You put the data you're operating on last. That's a change to the API of this function. Or there's things called Fluent APIs. I use the thing called the builder pattern. You've probably used some somewhere. Like I was using Supertest recently. Looks like that. Where you have one thing chained after another thing, chained after another thing, chained after another thing. The order on them isn't super important. Like that pattern's called the builder pattern. And overall, you could talk about the API for Supertest as allowing you to chain operations like this. Or if I go to the Express docs, API reference. They're talking about what things does Express expose. Those things are part of Express's API. It gives you those methods and these methods and these methods. All of that comes with Express. It's part of Express's API or Ember.js. API reference. It's a front-end framework. But these are all the things that come with Ember. These are the contracts that they're offering. Look at this, cool. So what comes along with this contract? Well, this class is guaranteed to have these methods and these properties and generate these events as documented like this. That's the API documentation for Ember.
Would I be correct if I said that a framework is a collection of APIs?
Yeah, that's not wrong. You could also talk about it in like the singular. You could say like this framework has the following API. But the reason you can do both of those is because of this like fractal nature of it. What's the black box? What inputs does it take in? What outputs does it poop out? Cool. Hopefully, you're a little bit better at talking about code now. I know you are because I saw it happen. All right, survey's coming out. Thank y'all very much. Cheers.